The first thing that we need to know about solutions is that they are impure, which means that they're technically mixtures. You are taking a substance in small quantity, which you're mixing in a substance in large quantity, assuming that it will dissolve into that. Now, the substance that is in small quantity, we call it solute, and that's the thing that dissolves into the substance with larger quantity, which we call solvent. And for it to become a solution, solute should dissolve in solvent, which means that it must have some intermolecular forces that will interact with solvent and so that it dissolves. If it is insoluble, then it will not make a solution, it will just be a mixture in which the solute will become a precipitate and the solvent will just be that. And together, if they're soluble, they make solution. Now, what it means is that because of the effect of diffusion, this solute will simply dissolve into the solvent and be distributed around it. So let's take an example. Let's suppose we have 1 gram of glucose, which is C6H12O6, and I add it to 10 cm cube of water. Now, over here, water is the solvent and glucose is the solute. Now, this 1 gram is basically telling me the quantity of glucose that I have. Now, while this is mass, another way to represent the quantity, which we usually prefer in chemistry, is mole. And to find out mole, as you already know, what we'll do is we'll take the mass divided by mR or AR in case of atomic substance, and we will get, in this case, 1 over 180, which is the mR of glucose, and that will be the number of mole in 10 cm cube of water. Now we assume that once you have dissolved that solute in the solvent, it mixes thoroughly and it is uniformly distributed. That is very important. Before you do any calculations, before you take that liquid, pour it into another piece of apparatus, you need to make sure that it is uniformly distributed, which means diffusion has taken into effect, you have stirred it thoroughly, and it is completely mixed. Once that happens, we can get to the idea of concentration. Concentration is basically telling me how much amount of the solute I have in the volume of solution. Now, this particular definition of concentration is called molarity. And the reason it's called molarity is because you're taking the amount of solute, which we measure in mole, and the volume of solvent, which we usually measure in cm cube or dm cube in the lab. Why? Because they are units that we can easily work with in the lab. 1 dm cube is equal to 1 liter, and you're all familiar with the liters that we use to measure the volume. Now, there's another way of measuring the concentration. Again, concentration is just about the amount of solute that you have in how much solvent you have. And that one is basically taking into effect the mass of the solute in the volume of solution that you have. And in this case, we call it normality. And normality is basically when you take the mass of the substance, and usually we do that in grams, and divide by the volume, which we usually take in dm cube. So there's 2 ways we can identify concentration. One is in mole per dm cube, and one is in grams per dm cube. And there's a very easy way of conversion. You take the molarity, and just like mole is mass over mR, molarity is normality over mR. And that is how you convert one to another. But again, the idea again is that you are taking a solute, you're dissolving into a solvent, making a solution which it is uniformly distributed, which means that 1 gram of glucose that I had, that I distributed in 10 cm cube, will now be distributed throughout those 10 cm cube. So if I take 5 cm cube out of that solution, I'll be taking half volume, which means I'll be taking half the mass, which is half grams. So if I take that, that is the idea of taking a sample of the solution. And the sample is always going to get the same quantity of solute as is in the ratio of the total quantity. So if I take 1/10 of the volume, I'll be taking 1/10 of the moles. If I take half of the volume, I'll be taking half of the moles. So that is how solutions work. and how you can distribute these solutions into smaller and smaller portions. But one thing that remains the same, whether you make a smaller portion or a larger portion, is concentration. And concentration plays a very important role for moles. For all the calculations of moles, concentration is an indicator that how much of the solute you have, how much is the thing that is actually taking part in the reaction. For example, in the case of acids and bases reacting together, in acids or bases, the reacting particles are those acid and base particles. But the solvent in there, for example, in the case of aqueous solution, which we represent as AQ, these aqueous solutions are when acid or base is distributed, mixed together in the water as the solvent. And what that does is that it allows those particles to move around. When they move around, they collide with each other. But how many moles of that thing you have, that's basically concentration. Now, when it comes to molarity, we have a very neat formula to make sure that we do the calculations correctly, which is N equals to CV, in which it means number of moles of the solvent that you have is equal to concentration. Again, this concentration is in molarity times volume of whatever solution or the part of the solution you have. Now, what it makes sure is that this is the only formula that allows us to find out the number of moles in an impure substance, in a mixture. But knowing this, we can easily figure that out. Now, one thing that you can do with solutions is that you can take smaller portions. Another thing that you can do is when you can take a solution of a concentration that you know and then add more water to it. When you do that, that process is called dilution. And dilution is pretty straightforward to calculate. What you're doing is that you're taking the same amount of solute, but you're adding more volume of the solvent, or you're making a greater volume of the solution. In this situation, what you have to make sure that you have to remember is that the number of moles before dilution is same as number of moles after dilution. Or sometimes we also say that the number of moles in the first situation is same as number of moles in the second situation, which means that if you know the concentration and the volume before you dissolve it into greater volume or before the solution is diluted, it is going to be the same as concentration multiplied the volume after it has been diluted. So most of the time we know how much water is added. For example, here's this example. Let's suppose we dissolved 5 moles HCl is dissolved in 10 dm cube solution, which is then diluted with 500 dm cube of solution. Calculate the new concentration. Now, this is a pretty straightforward question. First of all, let's figure out what's our concentration before the solution. So the concentration before the solution is simply that you have number of moles equal to concentration times volume. So concentration is number of moles, which is 5, divided into 10 cm cube, which is 0.5 moles per dm cube, which is the unit for concentration or molarity. And you have 10 dm cube as the volume of the solution. So we know in dilution, number of moles before is same as number of moles after. So number of moles before and after is going to be just 5, but the concentration and the volume will be different. So before the solution happens, you have 5 moles, or if you want to go through the longer route, you can just say that I have concentration 0.5 and volume as 10, which is again going to be 5. And this is equal to the new concentration, which I do not know, and the new volume, which is 500. So once you do that, 5 is equal to 500 times the new concentration, which is going to be 5 over 500, which is 0.01 mole per dm cube. Now you can clearly see what happened here is that initially you had 5 moles in 10 dm cube. So 5 moles were distributed in 10 dm cube of the solution. But now because you have added more water and made 500 dm cube, the 5 moles are now distributed throughout. And they are distributed in the ratio. So because you increase the ratio or increase the volume by 50 times, the concentration has dropped by 50 times. And that's a pretty straightforward way of understanding how dilution works. So in concentration, you have three things. You have moles per dm cube, which is molarity. You have grams per dm cube, which is normality. And you have dilution, in which the moles remain the same.